Hi, welcome to ACE Online. Myself Krishna Reddy, faculty of ACE Engineering Academy for Power Systems. Okay. Now, let us discuss about a topic called distance protection. Okay. First, let us see when the distance relay will be operated and what are the applications of distance relays and what are the types and what is the comparison of these distance relays. Now, let us go in detail about this. Okay. So, first question is when the distance relay will be operated, when the distance relay will be operated. So, here distance relay will be operated whenever the distance seen by the relay is less than the set distance. Suppose if you are protecting this transmission line using a distance relay, okay. Distance relay is placed at this location. During normal condition, this is the set distance, this is the set value, okay, this is the set distance. So, when short circuit fault takes place, what happens? The observed distance during fault will be less than the set distance, okay. So, what we can say, distance relay will be operated, distance relay will be operated when distance seen by the relay is less than the set distance, okay. Is it clear? So, whenever the fault takes place, the observed impedance will be less than the set impedance, okay. Here distance will be in terms of impedance, reactance and admittance. We have three different distance relays. One is impedance relay, reactance relay and admittance relay. So, distance relay will be operated when distance seen by the relay is less than the set distance, okay. Now, what is the application of distance relays? Where do you use these distance relays? Mainly, these distance relays are used in protection of transmission lines, okay. So, the answer is distance relays are used, where they are used? Distance relays are used in protection of transmission lines. In transmission line protection, we are going to use the distance relays, okay. Here, in case of distance relays, both operating force and restraining force will be developed by what? Electrical quantities itself, okay. F0 operating force and Fr restraining force will be developed by the electrical quantities itself. So, here we may be using voltage, current and directional element. So, Vi cos of phi minus tau. So, by using these quantities, we are going to develop what? Operating force as well as restraining force. And one more important point is this distance protection is a non-unit type protection. Distance protection is what? Non-unit type protection, okay. Distance protection is non-unit type protection. Non-unit selectivity means what? The relay may operate for faults within its zone and outside its zone also, okay, based on the condition, okay. So, where the distance relays are used in protection of transmission lines, operating force and restraining force will be developed by the electrical quantities itself, and here distance protection is a non-unit type protection. Here distance relays three types: impedance relay, reactance relay and admittance relay. Now, let us go for the analysis of impedance relay. So, where the impedance relay is used and how the impedance relay is developed, let us observe. So during normal condition, first let us take, during normal condition, suppose if you are protecting this section of line, if you want to protect this section of line by using an impedance relay placed at this location, okay. So here V be the voltage, during normal condition what will be the current? Steady state current, okay. During normal condition what will be the current absorbed by the relay? Steady state current. So now what is the impedance absorbed during normal condition? Z is equal to V by I steady state. Steady state. This is nothing but steady state impedance. This is nothing but steady state impedance. So during normal condition, what is the impedance absorbed by the relay? Steady state impedance. This is nothing but set impedance of the relay. This is known as set impedance of the relay. Now if you consider the same line with fault, okay, if you consider the same line with fault, then due to fault, what happens? Let us observe. Due to fault, what happens? Let us observe here. Suppose if you consider this section of line, V is the voltage at this bus and a relay is placed at this location. Now if you consider a short circuit fault, here when the short circuit fault is occurred, then what happens? The current observed here, it will be subtransient current. So current observed is what? Subtransient current. So during fault what happens? First initially the subtransient current flows. So here the subtransient impedance is observed by the relay, V by I subtransient. So as we know, the subtransient current will be very high. Subtransient current will be very high when compared to what? Steady state current. When compared to steady state current, the subtransient current is very high. So as the subtransient current is very high, then the subtransient impedance will be less than the set impedance, okay. So subtransient impedance will be less than the set impedance. So can we say that the impedance relay will be operated whenever the impedance observed by the relay is less than the set impedance or not? So whenever the fault takes place, the impedance observed by the relay will be less than the set impedance, okay. So we can make that point. Impedance relay will be operated when the impedance observed by the relay, is less than set impedance, okay. So impedance relay will be operated when the impedance observed by the relay is less than the set impedance. We can say that the impedance relay is operated. Here in case of distance relays, I have said both operating force and restraining force will be developed by what? Electrical quantities itself, no? So here the operating force is due to current, and restraining force is due to what? Voltage. Operating force is due to what quantity? Current, and restraining force is due to voltage. So how we can develop this impedance relay? We can use a balanced beam type structure for developing the impedance relay. So a balanced beam type structure can be used. Here this is the balanced beam. In olden days we are going to use a taras. So the same structure here. One side we will develop the operating force, on the other side we will be developing the restraining force. So here let this be the operating coil placed. Here operating force is due to current. So this coil is excited with CT and it is subjected to what current. So it will develop what operating force. It will develop the operating force. And here on the other side, we have the restraining force developed by using a restraining coil subjected to PT, that is voltage. A restraining coil, it will develop the restraining force. So apart from this, here we have a trip circuit. So here this relay contact has to close the trip circuit. So one end we are attaching the relay contact. This relay contact should close what trip circuit whenever there is a short circuit fault. So during normal condition this balance will be in this position, but when short circuit fault takes place, what happens? Current magnitude increases, voltage magnitude decreases. Then the force on this side will be increased. So this relay contact will close the trip circuit and the relay will operate for short circuit fault. So this is how a balanced beam type structure can be used. What type of relay here? Balanced beam type electromagnetic attraction relay, attraction type relay. So balanced beam type electromagnetic attraction type relay can be used for implementation of what impedance relay. So impedance relay will be operated whenever the impedance observed by the relay is less than the set impedance. Okay. So here in case of impedance relay, operating force is due to what quantity? Current. And restraining force is due to what quantity? Voltage. So how can we implement this impedance relay? By using a balanced beam type electromagnetic attraction type relay. Okay. So whenever the short circuit fault takes place, the force developed by this operating coil will be more when compared to what restraining coil. Then this relay contact will close the trip circuit and the relay will be operated. Okay. Now let us look into the characteristic of this impedance relay. So here the operating force is due to current. So we can write operating force as K1 I square, and restraining force is due to voltage. You can write it as K2 V square. Operating force is due to what quantity? Current. So this is a relation for operating force, and Fr is equal to K2 V square. So for relay operation, what condition must be satisfied, sir? For relay operation, what condition must be satisfied? Operating force should be greater than the restraining force. So when operating force is greater than restraining force, the relay will operate. Okay, here K1 I square must be greater than what? K2 V square. For relay operation, K1 I square must be greater than K2 V square. So what we can write here? K1 by K2 greater than V by I whole square. So under root of K1 by K2 should be greater than V by I. V by is nothing but what? Impedance. So we can write under root of K1 by K2 is greater than Z, or when Z is less than under root of K1 by K2, the relay will operate. So here whenever the impedance seen by the relay is less than the set value, the relay will be operated. So here also mathematically we got the same. This is the set impedance. Whenever the impedance observed is less than the set value, the impedance relay is expected to operate. Okay. Now what is the characteristic of this impedance relay in RX plane? For that we will consider a boundary condition. So that is at verge of operation. So at verge of operation, if you consider, At verge of operation, what happens, sir? Both operating force and restraining force are equal. So F naught is equal to Fr. So that is nothing but K1 I square is equal to what? K2 V square. So what you get here? K1 by K2 is equal to V by I whole square you got. Okay. You can write it as under root of K1 by K2 is equal to V by I. So V by is nothing but what? Impedance. So we can write this equation as Z is equal to under root of K1 by K2. Z is equal to under root of K1 by K2. So from the impedance triangle R, X and Z, so Z is nothing but what? Under root of R square plus X square. So you can write the equation. So if you substitute this equation here, so under root of R square plus X square is equal to under root of K1 by K2. So we can simplify that and we can write simple R square plus X square. R square plus X square is nothing but under root of K1 by K2 whole square. So we got the equation. Now we need to plot this equation in Rx plane, that is nothing but resistance reactance plane. So if you plot this equation in resistance reactance plane, what do you get? Let us observe here. So the characteristic of this impedance relay will be nothing but a circle with center at origin. Circle with center at origin. So what is the operating region? If the point lies within the region, within the circle it will operate, or outside the circle it will operate. So here the operating region is inside the circle. Okay, operating region is inside the circle. So this is the operating region and this is the non-operating region. So here radius will be the set value. So what will be the set value here? The radius. So this is the radius. So radius is nothing but under root of K1 by K2. So that will be the set value. So whenever the impedance seen is less than the set value, the relay is operating. So operating region is inside the circle. So the characteristic of impedance relay in Rx plane is what? It is a circle with center at origin. So impedance relay characteristic is a circle with center at origin. Operating region is inside circle. Operating region is inside the circle. So impedance relay characteristic is what? A circle with center at origin. Operating region is inside the circle. So now once we go this characteristic, now coming to the application of impedance relay. Where do you use this impedance relay? Where do you use the impedance relay? That's what the point here. So I have said that distance relays are used in transmission lines. Here the transmission lines are of three types: short transmission line, medium transmission line, and long transmission line. So what is the application? Where do you use this impedance relay? Short or medium or long? Very important objective type question. So if you observe, impedance relay is used in protection of what? Medium transmission line along with a directional element, because this impedance relay is not a directional relay. Okay. So impedance relay is used in protection of medium transmission lines along with a directional element, along with a directional element, okay. So because the transmission network is interconnected, whenever you are going for interconnections, then we require a directional element, okay. Now let us go for the next relay, that is reactance relay. So we have discussed about impedance relay up to now. Now let us see where the reactance relay is to be used and what is the application of reactance relay, what is the characteristic of reactance relay. Here in case of reactance relay, operating force is due to current only, but restraining force is developed by using a directional element. Restraining force is developed by using what? A directional element, that is Vi cos of phi minus tau. So operating force is due to current and restraining force is due to directional element. Now let us try to get the characteristic equation of this reactance relay. So here, as the operating force is due to current, we can write F naught is equal to K1 I square, and restraining force is due to directional element, you can write it as K2 Vi cos of phi minus tau. So for relay operation, what condition must be satisfied? For relay operation, what condition must be satisfied? Operating force should be greater than the restraining force. When F naught is greater than Fr, the relay is expected to operate. That is nothing but K1 I square is greater than K2 Vi cos of phi minus tau. So here, if you can evaluate this, what do you get here? K1 by K2 is greater than V by I cos of phi minus tau. V by I is nothing but what? Impedance. So here K1 by K2 is greater than Z cos of phi minus tau. So tau value must be how much here? For reactance relay, tau must be 90 degrees. Tau must be how much? 90 degrees. Then only we call it as what? Reactance relay. Otherwise, it will be an angle impedance relay. It will be an angle impedance relay. Tau value must be 90 degrees. So this is must. Okay. So if tau is 90 degrees, what do you get here? K1 by K2 greater than Z cos of phi minus 90. Cos of phi minus 90 is what? Sin phi. So what do you get here? K1 by K2 greater than Z sin phi. So what is Z sin phi? So from the impedance triangle, if you observe resistance, reactance, impedance and phase. So what is sin phi here? Sin phi is x by z. So x is equal to z sin phi, that is reactance is equal to z sin phi. Okay. So from this what we can write the equation here? K1 by K2 greater than x, or when reactance observed by the relay is less than its set value. Here K1 by K2 is known as what? Set value of the relay. So this K1 by K2 is known as what? Set value of the relay. So whenever the reactance observed by the relay is less than its set value, the reactance relay is expected to operate. So here reactance relay operating force is due to what? Current, and restraining force is due to what? Directional element. So when the reactance relay is operating, whenever the reactance seen is less than the set value or more than the set value. So here we have got a conclusion that whenever the reactance seen by the relay is less than its set value, reactance relay is operating. Okay. So here for reactance relay, tau must be 90 degrees. If tau is not 90, that is maximum torque angle is not 90 degrees, then it will be an angle impedance relay. Okay. For reactance relay, tau must be 90 degrees. So what point you can make? Reactance relay will be operated when the reactance when the reactance seen by the relay is less than set value. So whenever the reactance seen by the relay is less than its set value, the reactance relay is expected to operate. Okay. Now let us go into the characteristic development here. So here the operating force is due to current F naught is equal to K1I square, and restraining force is due to directional element K2 Vi cos of phi minus tau. For relay operation, F naught should be greater than Fr. But if you consider a boundary condition, that is at verge of operation, what do you get? Operating force is equal to restraining force. So here that is K1I square is equal to K2 Vi cos of phi minus tau. So now tau must be how much here? Tau must be 90 degrees. Tau must be 90 degrees here. So if tau is not 90 degrees, what do you get? Then K1 by K2 is equal to V by I cos of phi minus 90. Cos of phi minus 90 is sin phi. So K1 by K2 is Z sin phi. K1 by K2 is Z sin phi, that is reactance. So here K1 by K2 is equal to X. So X is equal to K1 by K2. So by using this relation, let us try to draw the characteristic equation. So here if you observe in an Rx plane, that is resistance and reactance plane, if you want to plot X is equal to K1 by K2, how that equation appears, let us look at here. So X is equal to K1 by K2 is nothing but a line parallel to what? Resistance axis. So in case of reactance relay, the characteristic of the relay is a line parallel to resistance axis. So what will be the operating region? Below the line or above the line? So operating region is below the line. So reactance relay operating region is below the line. Above the line it is non-operating region. Above the line it is non-operating region. So this is about the characteristic of the relay. Now let us discuss about the application of reactance relay. Where do you use this reactance relay? So application, reactance relay is used in protection of short transmission lines. We have three lines now: short line, medium line, long line. Reactance relay is used in protection of what? Short transmission lines. Okay. Reactance relay is used in protection of short transmission lines. Okay. In short transmission line protection, we will be using this reactance relay. Very important, very important. And the operation of reactance relay is independent of resistance phasor. Operation of reactance relay is what? Independent of resistance phasor. That's why the reactance relay is also used as an earth relay. Okay. So its reactance relay operation is independent of resistance phasor. So operation of reactance relay is independent of resistance phasor. That's why it can be used as an what? Earth relay. So operation of reactance relay is independent of what? A resistance phasor. That's why it is used as what? Earth relay. And what is the application? It is used in what? Short transmission line protection. Okay. Now let us go for the third one, that is Moore relay. It is also known as admittance relay. Moore relay is also known as what? Admittance relay. In case of Moore relay, how the operating force and restraining force will be developed? What is the characteristic? Let us observe in detail. Here, the operating force is due to directional element, that is Vi cos of phi minus tau. So, operating force is due to what? Directional element. This is the directional element. Directional element. And restraining force is due to voltage. Okay, restraining force is developed by using what? Voltage. Operating force is due to directional element and restraining force is due to voltage. So, how the Moore-Rayleigh characteristic appears and what is the application? Let us look at now. So, here the operating force you can write as F naught is equal to K1 Vi cos of phi minus tau, and restraining force is due to voltage, Fr is equal to K2 V square. So, for relay operation what condition must be satisfied, sir? For relay operation what condition must be satisfied? When operating force is greater than restraining force, the relay will be operated. That means K1 Vi cos of phi minus tau must be greater than what? K2 V square. When you can satisfy this condition, the relay will operate. Now, let us look forward here. So, K1 by K2, K1 by K2 cos of phi minus tau must be greater than V by I. V by is nothing but what? Z. So, you can write it as K1 by K2 cos of phi minus tau should be greater than Z, or when Z is less than this value, K1 by K2 cos of phi minus tau, the relay will operate. So, this is the condition that must be satisfied for operation of Moore-Rayleigh. For operation of Moore-Rayleigh, this is the condition that must be satisfied. Now, let us try to develop the characteristic for operation of Moore-Rayleigh. Okay, that is, what is the characteristic of Moore-Rayleigh in R-explain. So, here at verge of operation, operating force will be same as what? Restraining force. Operating force will be same as restraining force. So, here operating force is K1 Vi cos of phi minus tau. Restraining force is K2 V square. So, here K1 by K2 cos of phi minus tau is equal to V by I, that is nothing but Z. So, here let us expand this cos of phi minus tau in the form of cos of A minus B. Then what you get here? K1 by K2 cos of phi minus tau is what? Cos of A minus B, cos A cos B, cos phi cos tau plus sin phi sin tau. Sin phi sin tau is equal to Z. So, here cos phi can be written as R by Z, sin phi can be written as X by Z. Okay. So, then you can rewrite the equation as K1 by K2 cos phi is R by Z cos R by Z, just wait a minute, R by Z sin tau, sorry, cos tau here. So, this is cos tau R by Z cos tau plus K1 by K2 X by Z sin tau is equal to Z. So, take this Z on the other side and square it, you will get R square plus X square minus K1 by K2 R cos tau minus K1 by K2 X sin tau is equal to 0. So, this is the characteristic equation. Now, we need to plot this equation. So, if you plot this equation in Rx plane, what do you get? In resistance reactance plane. So, what is the characteristic of Moore-Rayleigh in Rx plane? It is nothing but a circle passing through origin. So, operating region is inside the circle, non-operating region is outside the circle. So what is the characteristic of Moore relay in R-explain? It is nothing but it is a circle passing through origin. Operating region is inside the circle. This Moore relay is inherently a directional relay. Okay, so Moore relay is inherently a directional relay. Okay, directional relay. Moore relay is inherently a directional relay because it's having only the characteristic of operation in first quadrant. Okay, not third quadrant operation is not there. So Moore relay is inherently a directional relay. So now, what is the application of this Moore relay? Where do you apply this? Moore relay is used in protection of what? Long transmission lines. Okay, so Moore relay is used in protection of what? Protection of long transmission lines. Long transmission lines. In long transmission line protection, we will be using the Moore relay. So this is the analysis of what? Moore relay. Now let us go for the comparison of distance relays. How can we compare? So we have studied about three relays. One is impedance relay. Second one is reactance relay. Third one is Moore relay. So this is the relay type. So here impedance relay, reactance relay and Moore relay we have three different types of relays. Now here let us look at the comparison of these three relays with respect to different aspects. Let us try to compare. So generally the objective type questions are asked here. So how the operating force and how the restraining force is being developed. So here in case of impedance relay, operating force is due to current and restraining force is due to what? Voltage. In case of reactance relay, operating force is due to current, restraining force is due to directional element, Vi cos of phi minus tau. In case of Moore relay, operating force is due to directional element, that is Vi cos of phi minus tau. Restraining force is due to what? Voltage. So this is the operating force and restraining force comparison. And which relay is directional and which relay is non-directional. So impedance relay is non-directional relay, reactance relay is non-directional relay, Moore relay is directional relay. Okay, now let us go for the last comparison, that is application comparison. So impedance relay is used in protection of medium transmission lines and reactance relay is used in case of short transmission lines and Moore relay is used in case of long transmission lines. In long transmission lines, we are going to use the Moore relay. This is the comparison with respect to some aspects. Okay, so this is about an overview of distance protection. Okay, so thank you for giving me this opportunity. Okay.
My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you.